We have one question from application of trigonometry, class 10th. It says the angle of elevation of a cloud from a point which is 60 meter above the surface of the lake is 30 degree. So what we can do, let's say if I make the lake first, the surface of the lake, let's say this being the surface of the lake, and from a point which is 60 meter above this surface of the lake. So this is above the surface of the lake. So I can write the point of observation as A and say BC, or you can say BD. Let's say BD is the surface of the lake, and this length is given as 60 meter. Point of observation is A. From this point, a cloud is observed, and the cloud is observed whose angle of elevation is given as, this is 30 degree. So let's say if I make a cloud here, for that I have to make a vertical line. Let's say I made a vertical line here, and then we have to make an angle of elevation. For that, I'll first be joining these 2 points. Let's say I've joined these 2 points, where C I'm taking as the cloud. And for that, I have to, in order to write the angle of elevation, we must make a horizontal. So I've made a horizontal here. The angle of elevation, which is given as, this is 630 degree. Now, as we read the question further, what do we see that this is 60, and so let's say this point as L, this is L. From the same point, the angle of depression of its shadow or the image is a better word because there's a reflection here. So from a point, same point, that is A, we have to find the its image, and clearly from the laws of reflection, what do you know? The image is vertically, it should be vertically below. Let's say I mark this point as C dash, indicating the image of this cloud, and will be joining A with C. We'll be joining these 2 points, and we'll mark this angle as the angle of depression, which is found to be 30 degree. So 60 degrees mentioned over here, 60 degree. Now, when we read the question later, and we find that we have to find the height of the cloud from the surface of the lake. So what we have to get is this length is what we have to find out. That is surface of the lake. As you know, BD is the surface of the lake. Not to forget that, you know that BD is the surface of the lake, this being the surface of the lake. Therefore, CD is what we have to get. Clearly, we know a part of it, so we can write the remaining part, that is CLSH. Right. So in order to get the value, first I need to consider a triangle where we can, where we know the angle of elevation. Clearly, we can start with this. Here, the angle of elevation will apply on this. But before that, there is a property that you should know, that from the laws of reflection, you know that the distance of the object from the surface of reflection, could be a mirror or any other object, is same as the distance of the image from the surface of reflection as a mirror. As you know that we are going to consider this triangle also, so it's better if we determine the length of its perpendicular in advance. So what we can see that from this part, we have the length CD is same as C dash D, and from the figure it is H plus 60. Now since we are interested on this part, whenever we find this is the part of the triangle, so that is C dash L, which is C dash L, that will give you CD, C dash D, which is H plus 60 plus CD or LD, that is 60. I'll tell once again. Here we know, let's say, we know from here to here as H plus 60 and this part is 60. So therefore the total length will be h plus 60 plus 60. So we can say that we know the length of CL as h plus 120 meter. Now I'll first find out the angle of elevations which we know, and then we'll be applying in triangle ALC. It's a right angle triangle. So we can use tan 30 degree as the angle of elevation here, which is equal to perpendicular. As I can see in the figure, perpendicular is H and the base is AL. You may first write it as CL as from the figure. Tan 60 is 1 over root 3 and the perpendicular, which is H, is equal to over AL. With cross multiplication, we'll get AL as root 3 times of H. So we can mark this as equation 1. Now we'll take the another triangle here. Let's put this in a box first, the information which we have obtained. Right. In the next part, we're going to take another triangle. And in this triangle, let's see. The triangle we are going to take now. Right. We're going to take the another triangle, and this time it is in triangle. We have ALC. ALC dash. This is another triangle we have taken. In this triangle, we'll again know the angle of depression, that is 60 degrees. So tan 60 will be perpendicular, which is according to the figure, it is L C dash over the base, which is AL. Now, if we replace tan 60 with its value, which is root 3, and CL dash from here, this is C dash also, as H plus 120 over AL. Now we can do cross multiplication and we'll get AL is equal to H plus 120 over root 3. So we got the value of AL and we'll mark this as equation 2. So I'm marking as equation 2. Now from 1 and 2, we can equate it. If I equate these two, right, from equation 1 and 2. So from these two equations, as we can see here, both of them is AL and we can equate them. So let's write down, this is root 3 times H should be equal to H plus 120 over root 3. By cross multiplication, root 3 into root 3 is 3. So 3H is equal to H plus 120. So 2H is equal to 120 or H is equal to 60 meter. So once we got this value of this as 60 meter, let's see what we had to find out actually is in the first part as the height of the cloud from the surface of the lake. So height of the cloud from the surface of the lake will be CD, right? So we have to get the length of CD, which as we can see from the figure is H plus 60, and we got H as 60. So it's 60 plus 60, that is equal to 120 meter. Now we have another part where we have to find the distance of this cloud from the point of observation. So this time we have to get this length, that is AC. Now we can apply a sine here. As we know the perpendicular, we have to get hypotenuse. So sine 30 is equal to perpendicular, which is H, whose value we have already calculated as 60. So in the first part, we may write H over the hypotenuse, which is AL. Now replacing sine 30 with this value, that is half, and H with this value, which we have already calculated as 60 over AL. That's yeah. So we'll get this AL as 120 meter. So this is what we have to calculate, and we have calculated two parts. The length of AL is what we have to determine, and that is equal to 120 meter.